All right, so how are things going? For those who are here. So we've got 2 weeks left. Yeah, for better or worse. So we're going to try to finish up networking this week. Talking a little more about sockets, creating sockets. I want to play around a little more with client-server stuff and show you some of the ways in which client-server is kind of the backbone of what we do. And then talk about like the URL class in Java. See what we can do with that. Maybe play with some other packages. But just sort of close things out this week, and then next week PA5 presentations and wrap up and any final comments. So we are coming to the end quickly. So finished grading PA5, and that looks good.
You mean
PA4. I have not graded PA5 yet.
Yeah.
I have gotten some of them turned in.
Everyone gets 0.
Yeah, nobody did it.
Can you just tell me how I'm going to do PA5?
Yeah, you just run the non-deterministic Turing machine.
Oh, I got 100%. I'm not going to do
Yeah. So yeah, PA4 looks good. Didn't really see any issues. Decision tree update worked fine. Most people were writing back to the file. So yeah, if you got questions on that, we can talk about it. But otherwise, yeah, it's just really good work. On the subject of groups, this is unrelated in particular, but you know, if you say groups, you can see what groups you belong to. So I can make a file, and my default group happens to be Nick, but I should be able to say change group, and admin, haha, and then look at it, and that changes the group ID. And then if you have group sharing, this should work. So you can do that for the last project, man. Then we get a network connection and hop onto the server.
Can you go to the terminal again for a second?
Yeah.
Oh.
I feel bad, I'm never on the server anymore. Nobody's playing Rogue either. That work? Cool.
Okay.
All right. Code sharing. So for the record, your accounts on the server will probably stick around for a few months after the quarter ends. Probably around August, I clear things out for the next year. So if you want to pull down your files, do it, you know, sometime before then. Well, you can still like try to log in. You can like go in and hack it or stuff.
Would it be alright to keep the accounts even if they've been cleared out for future use if we're staying here in Clark?
It is nothing.
Oh, if you're staying here at Clark, sure. Shoot me an email.
Cool.
And just let me know that.
Just for like a space for me to test C code and all that.
Yeah, yeah, totally.
Just Eclipse.
Yeah, that's fine. So let's talk a little more about client server in general, right? So I've mentioned this is kind of a general mechanism through which most of what we do on computers today is done. So netstat, right, lets you see active connections or connection requests. -A makes it active. -N says show me the numbers rather than the coded names. And first one that pops up is port 25 apparently is listening for connections, as is 953 and 3306 and some of these others, 22. And TCP6 is this 6-piece network address protocol, as opposed to the old 4-piece 32-bit. And there's connections established on port 22. Okay, port 22 is the SSH daemon. Okay, so when you putty in through SSH, you're talking to the server that's listening to port 22, and it's creating connections to do two-way communication. 25 is something called SMTP, Simple Mail Transfer Protocol. Transport is what I always say. I don't know if that's right. It just says SMTP. And if you don't do -n, you get, you know, a more readable description. So that third one is for making database requests, right? There's a database server, and you can talk to that. Let's play with port 25. So I'm on the server right now, and let's say telnet localhost 25. So I'm just using telnet as a way to do two-way communication. And it says localhost, local domain, ESMTP, postfix, Ubuntu. And typically servers, right, they just kind of sit there and they wait. And they expect you to do something. And if you just do random stuff, it'll say command not recognized. So SMTP, this is how mail gets sent on a local machine. So I can say hello. I don't know. I'll just say nick.com. I'm introducing myself to the server, and the server is responding with this message type 250, which tells me the internet address of who I'm speaking to, localhost.localdomain. Well, that's kind of meaningless. It's not a real internet address, but that's what it calls itself. So I can say mail from, who should we send mail from? Oh, we can send it from anybody we want.
Like users on the server or anyone?
Okay, we'll send it from Darth Vader.
That answers your question.
Maybe Darth is on to us. Oh, can't have spaces.
God sender, yep.
Okay, that's okay with that. And I'm going to send it to myself. Anybody else want a copy? I don't know if it'll actually go to someone else. What's your...
Chris?
D. Chris?
Yeah.
Okay. Okay, uppercase. Okay, and then I can say data. And now I can type in the body of the message, and it should send an email. So, from subject, promotion to emperor.
Don't give that much power to David.
All right, and then you end by just a single line that has just a period on it. All right, so put a period in, and it's queued up our email request. So I'm going to close out my telnet connection, and hey, I've got some new mail, right? And if I say from, it's from Darth Vader. And I can say mail, and there's our message. So it's from Darth Vader at deathstar.com. All right. It's just a C program. It's just a program that's sitting out there listening for connections on port 25. and when certain transactions take place, it creates a file inside this directory /var/mail. It makes a file called Nick, and the mail program just looks through there and picks out messages. So if I go to var mail, there's 6 of us who have gotten messages at some point in the past, right? And these are owned by the respective users with no access to the outside world. But
Who's nobody?
nobody.
Nobody knows.
So if I look at this file called Nick, right, this is the syntax of it. It's from lines and to lines and so on. Headers, you know, something followed by a colon, and then a blank line, and then the body of the message, and then a blank line. And if I have multiple messages, they're just queued up one after another after another. It's a really simple mail protocol, right? Smtp. Now getting out to other machines, that's more complex now. But it used to be that when you said mail, you know, Darth at Death Star, it would find deathstar.com, it would talk to port 25, it would say I got some mail for Darth, and the same thing would happen. That doesn't really work anymore, right? Because this is horribly insecure, right? I just forged an email from Darth Vader, you know. But you know, this is where a lot of our spam comes from. You look at a message, and up here in the headers, you see that this is, you know, from someone at localhost.local domain. But when you look down here in the message body, it says, oh yeah, it's from someone at deathstar.com, right? Or clark.edu. I better go ahead and send them my password that they asked for because it's legit. It's just really simple to spoof. But that's all there is. Yeah, I can't look at nobody. Security information. Maybe I should be reading those. Oh, I wonder if those are like pseudo attempts or something.
Nobody checked them.
Oh yeah, okay. So when you try to sudo and you have permission, it actually does send an email.
Uh-oh.
Uh-oh. Let's see how many times Khan is on here.
It doesn't show like the previous one, right?
Oh,
Yeah.
all right, so that's how mail is set up, right? Like I say, it's just a C program. So what about port 80? So I'm in there way more than you are, by the way. So we can talk to port 80, right? 80 is it's the HTTP daemon. It's the port that listens for web page requests. So I'm talking to port 80 right now. I'm talking to the daemon on the machine, and if I just hit enter, it doesn't do anything. If I type in something it doesn't understand, it sends me back a web page, right, which says bad request, your browser sent a request the server could not understand, and some information. This stuff that it sent me is just plain text, right? And if I look at it in Telnet, I see all these things inside angle brackets, right? Well, that's just a markup language. If I grab all of this, and we're totally playing without a safety net now. So I'm going to make a file called test.html, and I'm going to paste all that stuff we just got inside this file. And I'm going to open this with Firefox. Firefox is primarily a program that can take that stuff that we saw, right, this kind of marked up text, and display it in an appropriate way. So over here where it says less than H1 greater than bad request slash H1, H1 is a tag that says make this a header level 1, which makes it bold-faced and in a larger font. And angle bracket HR, that's a horizontal rule. It says draw a line going horizontally across the page. That's why this line is sitting right here. So part of a web browser's job is to take that markup language and interpret it in a way that it displays, you know, what the server was asking you to display, by changing fonts, by putting in images, by putting in other clickable links and things like that. But the other thing that the browser does is when you you know, try to get to a page, it will basically make a connection to port 80, or actually 8080 if it's secure, on whatever server you're connecting to, and it'll ask for a page. Now, I didn't ask for a page, I said blah blah blah, right, which you didn't understand, but I could have done something like get /index.html, and I get something much more interesting. So all of this stuff that I got starts with doc type, site made with Mobirise website builder, and it's using Bootstrap, and somewhere down here we should see engineering 120, engineering 204, 250, right? This is
The very last line is 220.
yeah, this is the Clark web page that that's sitting on the Linux server. So when you go to linuxengrcs.com and you get this page, right, really all that happened was the browser connected to port 80 on linuxengrcs.com, said get/index.html, took all of this stuff that it got back and interpreted it in a way that caused it to display this. And when I click on a link, like if I click on flowchart, right, that's going to go off and make another request. In this case, it's going to request something under docs first courses.pdf with a get tag, and it should get back a bunch of stuff that's basically the PDF. And then Firefox knows that if it's a PDF, it should run, you know, PDF display software, and it turns into that. And that's just another bunch of C programs, right? All this stuff is written in C usually, and it's really just file transfers and interpreting. It's nothing that you haven't known how to write for at least a few months now. So here I am back on our good old laptop, right? But I can telnet to linuxengrcs.com, port 80, and do exactly the same. And I can get index.html, and right, even though I'm on a totally different machine. Or I could get /tilde_nix/shared/223/list/main.java. And there's some of the sample code that was posted on the Linux server.
So when you're on the server, you used localhost as
Mm-hmm.
your first argument, and here you use the server. What could be the benefit, or why would you want to use something else?
So the thing that you put after telnet is supposed to identify the machine you're connecting to. So the Linux server is known, you know, everywhere by the name linuxengrcs.com. There's something that maps that into an address. I could also have said 70.35.202.249, right? Because that's the actual IP address. If I'm on the machine, I can also do 127.0.0.1, right? Because that always refers to your current machine, and localhost always resolves to 127.0.0.1. So it's got at least 4 different ways of identifying it, depending on where you are. From here, if I try to do 127.0.0.1, it would be coming to my laptop, right? So there's local addresses and there's actual like internet addresses. And from here, if I try to connect to port 25 on the Linux server, well, let's do this, right? It'll sit there and it'll wait, and eventually it'll time out. Now we know there's a server sitting on the Linux machine listening to port 25, but I can't get to it from my laptop. And that's most likely a firewall issue feature. So firewalls basically control the flow of traffic into your machine from outside. Now from inside my machine, from inside the server, I can telnet out to other places, and that works perfectly fine. But for somebody to come in from outside and reach port 25, they have to go through this firewall. And one of 2 things is probably happening. One, traffic to port 25 is being deliberately blocked, right? Which is good, otherwise the whole world could be sending us like bogus emails, right? And you just make a program that just endlessly spams you with mail and you fill up your disk. Or if you have a router and the machine that you're looking at, Linux, is not directly connected to the internet, right? It's connected through a router, then the outside world can talk to that router but can't talk to things that are inside, unless you put up port forwarding. So port forwarding says, okay, if this router gets requests for port 25, send them on to linuxengrcs.com. Right, by default, there's no port forwarding enabled, and so you can talk to the router, but you can't actually get to the inside machines. That's why firewalls are firewalls. That's why they add a level of security, because it makes it hard for outside entities to contact the ports on your machine.
So with that, on that kind of port forwarding idea, if you had, say you were like for instance, like a programming assignment, right? You say you have a user connect to a port, and then they could forward to some set of ports. Right, and then just fill up those ports kind of like in an array for each user to have their own port. And so that then port would be open, right?
Right.
Okay.
Yeah. And so if you want to, you know, make a chat program where people from outside your machine can get to you or outside your internet can get to you, yeah, you can forward ports or ranges of ports. There, we finally timed out. And you know, most firewalls, you can say forward requests from this IP address or from this range of IP addresses, so you can control who gets forwarding. Or you can just turn on a DMZ, right, a demilitarized zone, and say anybody who wants to come in here is welcome. And if you're doing, you know, penetration testing, for example, and you want to know how secure your system is, you make a honeypot, right, system that's available for people to come in and attack, and you just turn on a DMZ, and you just start getting, you know, a ridiculous number of things coming your way. All right, so let's try some socket code. Okay, so let's construct a socket. Let's go to the server, and let's go to port 80. So we'll make a web browser here. We'll do a better one later in the week. So we're going to construct the socket. And put everything in a try-catch block. And then let's do a print writer. And let's do a scanner. PW equals new print writer. S.get. Get an output stream and write to that. So we're going to make our get, so get says give me a web page, right? We're going to look for index.html. I think I want this to be an input stream, but I'm not sure. All right, so we've got a next line. Alright, so basic socket code. So we'll open a socket on port 80 on the Linux server. We'll make a print writer and a scanner.
Let me see a quote on the other side received.
And
A semicolon off the import scanner.
you people are awesome, man.
We're not sleeping.
Yeah.
Partially.
Where am I missing a semicolon?
No, the import scanner. All the way up to the third line at the top.
Oh yeah, thanks. Wonder if this is how like Java's compiler works. It like sends your code to a classroom somewhere on the other side of the world, and people are like,
There at the top.
that one.
There, no, bottom, no, up, no.
All right, let's see how we did. Hey, nice, thanks. Okay.
Sure, I need new words.
Team effort. This is what we're going to do in exams.
I'm gonna call this client because this is a client, not a server. So I'm gonna run this and it's not gonna do anything, right? Presumably it's sitting there, it's sent out the GET request, it's waiting to get back some information, right? So here's a funny thing about the web. Got to do carriage return line feed at the end of your line. Well, you also have to do a flush. But I don't think a flush will do it. Oh, it did, never mind. Okay, I was doing something weird this morning. All right, so we sent that out, and guess what? It sent back our information. Now it said bad request, and it didn't understand what we asked for. When we said get index.html. So let's put the carriage return on the end of that. Now it understands what we're saying. And I sent back all this stuff.
So where's that carrot return to?
It's So the new line sends the end of the line that like causes the thing to receive our request, but it's expecting a carriage return at the end of the request, otherwise it doesn't understand what we asked for. Right? So this is a 12-line Java program or so that we're running that's pulling all this stuff off of the server. Right? We're accessing resources on the web from Java just using sockets, which is arguably kind of cool. So if I go to Nick shared index.html, I don't know what this will do. Yeah, that's what I thought. All right, if I go to nick/index.html, there's a little bogus test page that I have on the server. And if I go to ~nick index.html, alright, that's the same page. And there's conventions. If you don't specify a file name, it looks for index.html by default. And so in my directory, my home directory, I have a public_HTML. And underneath that, I've got an index.html. That's the file that I pulled when I asked for ~nick index.html. So username refers to a directory in that user's login account, their home directory with a subdirectory public_HTML. So if you want to put your own web page up, right, you put files under public HTML. And so underneath shared, that's the stuff you get to when you go to the shared area. And under 223, that's all code that I've posted for this course. And they're just plain files, right, or directories. So there's the lists. And it's just got files in there. All right, and engrcs.com is our website, and so on and so forth. So again, there's no magic here, right? I mean, it's kind of magical, but there's no magic. So questions about any of this? Is this mostly review? Is this new? Maybe, probably not. Conceptual questions. I still got to put up a couple of quizzes for the exam. You should know about the client-server model in general, though, right? Because that's PA5, and that's something we've talked about. But no details like where is the web page stored or what does this port number do? That definitely won't be on the test. All right, PA5 issues so far. Yeah.
Yeah, we were trying to figure out the best way to make it so that the server only accepts one connection. So we were using a shared piece of code for all 4 threads involved.
Mm-hmm.
And then we're trying to figure out how to make it so the server doesn't take more connections when we're using the shared code like that.
The server will only accept a connection when you call accept. So by default, it's only going to take one if you say accept once.
But then it has to be ready when one's done, right?
When it's done, then, so normally you do something like in your server. So make a server socket. Accept a connection, right? Open second thread. Do your two-way communication, right? So maybe your thread that accepted is reading from your keyboard and sending to the socket. You create a second thread to read from the socket and send your display, or vice versa. And then, you know, just kind of sit here and do your two-way communications. Loop until connection is closed. And then kill your second thread. And then you go back to accept. And so if while you're doing this, somebody else tries to connect to your server, they will be sitting there waiting and possibly time out at some point. But once you shut this down and you go back up to your accept statement, right now if someone tries to connect, you grab their connection and you start going from there. Yeah?
So when the clients go out, so the servers do that.
The server's never going to die, hopefully, right? It's always there once you start it, unless you Control-C it. So client 1 comes in, has a chat session, client 1 exits, server continues waiting for a new connection, right? So this is one way to do this, but there's other ways. So create server socket. Accept a connection. At this point, you could create 2 threads. One which says copy from standard in to the socket. The second one which says copy from the socket to standard in, standard out. And then go right back to accept. Now you're handling multiple connections, right? So client 1 makes a connection request, you accept the connection, you create a pair of threads. So now you've got a thread that's reading from your keyboard, sending to the client, reading from the client, sending to your display. You go back and accept. If another client now comes along and tries to connect, you've got 2 communication sessions going on at the same time. That gets tricky to do if you're just running from the command line. Because if you have 2 threads running that are reading from standard in and you type something, which thread picks that up? Right? And that's not just a rhetorical question. It's a good question. But if you're using GUIs, this is a good opening to a much more powerful chat program. Because before you create your 2 threads, or somewhere along the way, right, you create a new window, and this thread is reading from editor box, or a text box on your GUI and sending to the socket. This is reading from the socket and writing out to that same text field. And you know, that code is bound to those particular visual elements, and so you can type in that box and send to that box. And now if another connection comes along, you're going to create a new window and have a new text field that you can read keystrokes from and send output to, and you can do multiple sessions independent of each other without them getting tangled up. So But don't have to do that, right? You only need one session at a time to get full credit. But if you want to explore it, right, GUIs are going to make it a lot easier, just because it gives you a way to direct your input. Don't have to do that. You could prefix each message with the ID of the client you're trying to send to, right? Or you could just say whatever I type gets sent to everybody who's connected to me. So you have kind of a group chat effect. But somewhere along the way, you're definitely going to want 2 threads, right? Because you got to have independent standard into socket, socket to standard out. So creating a socket with a given internet address and a given port number, we can call that binding the socket to an address. And when you create a socket and you construct it with an address and a port, it's being bound to that pair of identifiers. So we can bind a socket, create 2 threads. Again, standard into socket and socket to standard out. Okay, so there's a trick here. Client makes a connection request, server's accepted it, you got 2 threads. Client's got 2 threads, so client's typing something, hello, hits enter, it gets sent to the socket. Server picks it up, displays it. Server types something and sends it, right? This thread is picking up from the socket, displaying it to standard out. Works great. Okay, you're done with the chat session, you want to close things down. So maybe you hit Control D, right? And you detect end of file. Or you say something like quit. But somehow you indicate on the client side that you're done communicating. Maybe you hit Control C. Or you hit the red stop button in Eclipse, right? So, let's say you hit Control D, end of file, or a magic word like quit. Presumably what you would want to do is close this socket, right? So socket.close. You can just kill this thread that's reading from the socket and copying to standard out. You don't really need to do anything more. You can close that socket. And now if the client tries to send something to that socket, it should get an error saying communication is closed. So the side where the client's typing, the server's typing and sending to the socket will eventually get an error after you try to send something. The side that's reading from the socket and displaying should get an error immediately, right? Because it's sitting inside a socket.get byte, and that's going to throw an exception, an IOEOF exception, something like that. So this thread is going to be able to be shut down pretty quickly. And even if the client just Control-Cs, right, when you Control-C the client code, that's going to shut down that end of the socket. And this thread that's reading from the socket is going to know that right away. But this is potentially problematic. Because this thing that copies from standard into the socket, what is that doing? So SC equals new scanner, and don't use SC. Use really good variable names in your code for this, because all your code's going to look the same, right? All 4 of these threads are going to look really, really close to each other. And while you're inside the server, these are going to be doing the same thing. So establish in your mind some sort of convention, right? Don't just say like, input or scanner or something like that, right? Socket from client, socket to server, something like that. But I'm just going to use SC because I'm lazy. So make a new scanner on system.in, right? And you're going to say something like, while SC dot has next line. Buffer equals SC dot next line. Socket dot print line buffer. Some usual loop, right, where you're reading from standard in and sending to the socket. Okay, here's the problem. This loop inside this thread is mostly sitting right here. It's waiting for the next line to be available from standard in. And so client's talking to you and you're just listening to it, right? And the client closes out their connection. And this poor thread is still sitting here waiting for you on the server side to type something. Now once you type something and you hit enter, it'll pick up that line, it'll try to do a print line to the socket, it'll throw an exception saying that connection is closed, and now you know that the connection has been shut down. But until that happens, this thing is still sitting here waiting for you to type something. So you want to try to figure out a way to shut down this thread when the socket connection goes away. And you can detect that. I mean, this second thread is going to know right away when the socket gets closed because it's trying to read from the socket and it's going to get an EOF, right? And it can certainly set a flag somewhere in shared memory, or it can run a method in this thread and so on. But you're still faced with this fundamental quandary, which is that you're sitting inside this hasNextLine method. And until you come out of that, no other code is going to execute in this thread. So this is something that we've touched on in 2.24. This is the idea of blocking I/O. And hasNextLine is a blocking statement. It says you're making a call to this method and you're not going to return from that method until the I/O operation that it's requesting is completed. Which means I can't run code that says, you know, if I've been interrupted, do something, or if this flag has been set, do something else, and so on, until I come back from that call. So the way to deal with this, there's at least two ways. The first one is the lazy engineering way, okay, which will work. This thread, which is reading from socket and sending the standard out, when it detects that the socket connection is closed, it can print a message saying client has exited, hit enter to continue. And when you hit enter, it's actually this thread that's picking up the enter, and now you're out of this next line, and you can go in here and you can check the socket and see that it's closed. Okay, that's just changing the problem. But it works. But if you want to be fancier about it, right, we can talk about non-blocking I/O. And the way we use non-blocking I/O is basically we change this standard into socket loop. Instead of calling hasNextLine, we can check to see if there's anything available from standard in. And if there is, we can go ahead and read it in. If there's not, we can go ahead and check our flag and say, has our connection shut down? And if not, we go back and we say, is there anything available? No. Has our connection shut down? And we make our loop this thing that just keeps checking to see if there's data available, see if the connection is shut down. If data is available, we grab it and we do whatever we want with it. If the connection has been shut down, then we go ahead and we clean up and we exit. So we'll play with some code tomorrow for non-blocking I/O and see how to use this. And if you're not there yet, don't worry about it, but it's a point that you'll get to probably towards the end of PA5. It's a detail, but it's a entry point to a whole bunch of other topics, so it's a good one to think about. All right, so I will see you tomorrow.